Alright, so numbers 24, 25, and 26 is where I'm going to start in this Chapter 1 test review video. For these numbers, the directions say use the diagram, tell whether the angles are vertical angles, whether they're a linear pair, or neither. Now if you remember, a linear pair are two angles that when they are adjacent to one another, they form a straight line, or their measures add to equal 180 degrees. Also, on another note, remember that if two angles are vertical angles, they are formed by two straight lines intersecting, and that they are across from one another. So, for instance, 1 and 2 are across from each other, and the lines that form them are straight. Okay, they must be straight. It must form a perfect X. Okay, so now, with all that in mind, let's look at number 24. Number 24 says angle 1 and angle 2. So let's go to our diagram. Here's angle 1, and it is formed by that. Angle 2, which is here, and it is formed by this. Now notice that those two angles both share this side. They are adjacent and share this side. So I want to look at the sides of the angles that they don't share. That would be this side and this side. Oops, that doesn't help very much to see. That would be this side on angle 1 and this side on angle 2. And if you notice, together they form a straight line. So therefore, angle 1 and angle 2 are going to be a linear pair, because the sides of the angles that are not shared with one another, notice this side is shared with both angle 1 and angle 2. The sides of the angles that are not shared form a straight line when put together. Okay, now the next one, number 25, says angle 2 and angle 5. Okay, so angle 2, again, is this angle. Angle 5 is this angle. Now if you notice, it looks like they form a perfect X. So if I connected those two and then these two, I have a perfect X that is formed. And angle 2 is directly across from angle 5, meaning they are vertical angles. And then number 26 says angle 1 and angle 4. So angle 1 is this angle. Angle 4 is this angle. Now if you look, they do not share a side, and they do not form a perfect X. Because if I started drawing this line, we're okay with a straight line. But if I start drawing here, I can't keep going straight. I would have to bend down. And if you look at what's in red, that is not a perfect X. So therefore, angle 1 and angle 4 can't be a linear pair, because they touch at the vertex, but they do not share a side and form a straight line. And they cannot be vertical angles because the sides does not form a perfect X. So angle 1 and angle 4 are neither. Alright, let's go on to number 27 and number 28. The directions for these two say, use the given information to find the value of X. Well, let's look at number 27. What is the given information in number 27? Well, this says that angle ABD is congruent to angle DBC. Well, if you remember, congruent means they have the same measure. So let's look at ADB. Well, ADB is this angle, and then DBC is this angle. They're adjacent. Notice they share a side. And they tell us that the two angles are congruent. That means that this angle must have the same measure as that angle. Well, if they're congruent and the measures have to be equal, in order to find X, I can just set up in the equation and solve for X. So ADB is 30 degrees, and it must equal DBC, which is represented by the expression X plus 25, and it's in degrees. So let's solve for X. So I want to get x by itself, I need to move the 25. I'm going across the equal sign, so I've got to change my signs. 30 minus 25 is 5. Bring the x down, 25 is canceled, so x must be equal to 5. Now notice my directions say find the value of x, so I'm good stopping there. Now if you want to check your work, you can come up and plug x in. Well, if x is 5, 5 plus 25 is 30, which means if this is 30 and this is 30, I must have did it right because they have to be congruent. All right, so now let's look at number 28. 28 tells me that the angle WXZ is congruent to the angle ZXY. So WXZ, which is this angle, is congruent to ZXY, which is this angle. That means that their measures have to be equal to one another. So WXZ, here, which is equal to 60, must equal ZXY, which is represented by the expression 3x minus 12. And now I want to solve for x. So I want to get the x by itself, so let's move this constant, going to the other side. So I add 12, so 72 equals 3x. Now I want to get the x by itself, I need to move to 3. This is multiplication, so to undo it, we do the opposite. So 72 divided by 3. Whoops, don't know what I'm doing there. So erase that. What I meant to say is 72 divided by 3 is 24. So x is equal to 24. And remember, the question only asks us to find the value of x, so therefore we're done. All right, let's go ahead and look at numbers 29, 32, 33, and 34. They say, the directions say, classify the polygon by its number of sides and then tell whether it is concave or convex. Well, number of sides is just the name based on the number of sides. However, remember, concave or convex means if a polygon is concave, some of the sides fold in on itself. For instance, that is concave. Convex means none of the sides cave in. So this is an example of convex. Remember, concave has the word cave in it, and a cave goes into a mountain. So concave means the sides point in at least one point. And then convex means none of the sides point in. All right, so let's start with number 29. So what I like to do, because sometimes when there's a lot of sides it can be confusing, I like to put little marks on my figure as I go around. So let's count the sides. 1, 2, 3, 4, 5, 6, 7. So a 7-sided figure is called a heptagon. I'm going to put in parentheses septagon because in some textbooks, the higher in math you get, sometimes you will see the word septagon because that's another name for 7-sided figure. Now, please do not get confused with these tick marks as meaning that I think that those sides are congruent, because they're not. I was just using it as tally marks, not tick marks. So that is a 7-sided figure called a heptagon. And if you notice right here, it looks like the figure caves in. So this is a concave polygon. All right, let's look at the next figure. 1, 2, 3, 4, 5. 5-sided figure is a pentagon. Now, and if you notice, none of the sides cave in, so this is convex. And then we have 33, and there are 1, 2, 3, 4, 5, 6, 7. Another 7-sided figure, and this time I'm just going to write septagon. And you know that it's also called a heptagon. And if you notice, there are 2 places where this figure looks like it caves in on itself, there and there. So this is concave. And then lastly, we have this 1, 2, 3, 4-sided figure, which is called a quadrilateral. None of the sides appear to cave in on itself. So this is a convex polygon.